Hey, how's it going, guys? My name's Daniel, aka HashLips, and welcome back to probably the last video of this Solidity Basics. By now, I've explained enough Solidity concepts for you guys to grasp what Solidity is and will feel comfortable when we do future tutorials on creating smart contracts. Let's carry on with this last little bit of the tutorial series by looking at how you can call other contracts. There are two main ways. One is a low-level way and the one is the easier way that you can use. I'm going to show the one way because it's most probably the one that you're going to use, but you can feel free to learn more about it on this documentation document. I highly recommend this document because it explicitly explains each little part of Solidity and it shows you how to use it. This was my guide that I followed when creating this tutorial. Anyway, let's carry on and look at how we can call other smart contracts with another smart contract. Let's say, for instance, that we have another smart contract and I'm going to call this my other contract, and then I'm going to just say this. So we have a my other contract and a my contract calls. You can go ahead and create the same file over here, my contract calls.sol, and give it the same structure. In this contract over here, I think we can just declare maybe a uint, and let's make it public. Let's make it a name, or not a name, maybe a age, for instance, and let's make the age 29. Now, once we have this, let's create a function inside this contract which says getAge. Now, the getAge function won't do a lot. It's going to be a very simplistic function, most probably a view, and we are going to return the age. So we are going to return age over there, like so, and we probably have to say what it returns. So returns. We're going to return a uint 256. Remember that the function is perfectly fine like this, but you can also add just age in here if you want to specify what you're going to return, just to make it more readable. All right, so now that we have our simple smart contract, how can we call it from the other one? Well, we can do it after this contract has been deployed on the blockchain. It has an address, remember? So what we can do in my contract is say function getAge from other, let's say getAge from other contract. And this is now not the contract's age, but my age. Should probably not reveal my age, but anyway, there we go. We can make this a view, and this is going to return to us as well. This is going to return a uint 256. Now, how do we get access to that other contract? As I explained, that each contract deployed on the blockchain, each smart contract has its own address. Now, after it's deployed and you know the smart contract's address, we can simply instantiate another contract if we know the ABI of that contract or the structure of it. But let's say we do know it and we have it in here, but we basically want to pass the address to it and then make sure that we use it. Let's go ahead and do so. So what we can do is we can pass in address over here, and this address is not going to be payable, but this is going to be the contract's address. Let's just make it contract address. Remix is a little bit laggy this morning, but contract address, there we go. And then what we want to do is we just want to go ahead and call it. Now, much like other variables, we can instantiate a type that we want to. And the type is actually going to be my other contract type. Then we can go ahead and call it other, and let's just make it smaller variable name. So let's just call it other, and other is going to be equal to my other contract, and what we have to pass in here is the contract address. Once we do that, we basically get that instance where that contract lives, and we can now do calls on it. So we can basically say, let's save this inside a variable. So let's go and declare a variable uint256. Let's make it age, and age is going to be equal to other dot get age, like so. Now, get age doesn't take in any parameters, so we are going to save it in here in our age variable. Then our function requires us to return the age, so we can simply return the age here. And that is it. That's how simple this is. So what we can do now is we can go to the compiler, make sure everything is fine over there. Let's go and deploy our other contract first, because we need its address. So we're going to deploy it, and here's the other contract, age and get age. But now what we want to do is we want to actually copy this address from this contract. Once we've copied it, I am going to just show you. This is the address of this contract. So I'm just going to put that in there just for you guys to know as reference, and maybe let's just put it here at the top. This will not be the same if you deploy this contract on your remix, so just keep that in mind, but I just want to have it here for reference. Then what I'm going to do is on the same blockchain, our virtual machine, select the other one and deploy that as well. Well, this is the wrong one, so I'm going to deploy my contract, deploy that one, and there you can see my contract calls. We can open it, and here we can say get address, get age from other contract. So if I call it, it will break because it can't find the actual instance. But like I said, if we copied this account now, this address where this contract lives, and we pass it in here and we call it, we get back 29. How cool is that? That means that you can actually go and call other smart contracts living on the same blockchain, use their functions if it's public, and you can start seeing how you can start building a very intuitive dApp with this knowledge. We're going to go on to the last part, and then we'll end the series off. You've seen this a lot, especially if we look at OpenZeppelin's contract. You see this import statement quite a lot, especially if we go into the ERC 721 contract. You'll see that it has numerous imports. You can import anything into your smart contract and use that smart contract, especially the code. Go and copy this URL over here, and once we have it, we can go back to Remix and create an import statement like so. You start off with the word import and then specify the path to that file. Now, if this file is living on the network, such as GitHub, you can go and import it like so, and you'll see that the artifact started creating because it started importing dependencies. You'll see that Remix adds its dependencies under the .dep file, and there you can see GitHub OpenZeppelin, and it truncates down until we get its import. Now that is perfectly fine, and you can now use that ERC 721 by saying my import is of type ERC 721. Remember that ERC 721 has a constructor function which allows us to specify a few things. The ERC 721's constructor expects a string and a string name and a symbol. We can go ahead and apply those by creating our own constructor like before, specifying our constructor like so, and then saying ERC 721 and giving it the types. If you want to see exactly and comply exactly to another contract's constructor, you can go and copy the parameters. Let's paste the parameters in our function. I like to append the underscore in the beginning of the variable name, so I'm going to do that. Then once we have it, we can pass it along to our ERC 721's constructor as well. And that's perfectly fine. What if we want to import a local file? It is exactly the same process. Let's say we want to import my loops. Well, we can go back to my imports file, simply go and add another import statement, and this time specify with these semicolons, well, not semicolons, these quotation marks, basically that we want to import my loops. How you do that is you say // usually meaning the same directory that this is in, because my imports is sitting in the same directory. If my imports was on an outside folder, we would actually traverse backwards, giving two full stops and a /. But we in the same directory, so we can do this, where we can say import my loop .sol. Like so. We can import it like this, or you can just simply say my loop.sol as well. I think if it won't break. Let's go and have a look. It can't find it, so you have to add the root folder. Perfect. Now that everything is fine, you can also specify that this is going to be my loop as well. You have to separate them with commas. And there we go, we've inherited a ERC 721 and my loops contract just by importing. How cool is that? Another thing we can have a look at, and this falls part of the same theme of this video, is how can we instantiate other smart contracts without it being on the blockchain, but let's say we want to use features. Let me create an example. Let's say I had a new contract over here, and this contract can exist in the same file or in another file where we can import it, but I'm going to create it here for simplicity's sake. Let's say this contract was an NFT and we declared this NFT. We want to say actually that this NFT might have an ID or DNA. Let's stick with the DNA. So this is going to have a DNA and we're not going to declare it yet. And it's also going to have a string which is going to be called name. And it's also not going to be declared. But we are going to add a constructor function, and in this constructor function we're going to pass it a string which we'll have to make memory. We're also going to say this string is going to be called name, and also we want the DNA. So we have to have a UN256 passed in as a parameter as our DNA. Now that we have this, and on instantiation of this contract, remember a constructor kicks off, we can actually go and set this. So I'll go ahead and set my DNA and my name. So I'm going to set the name equal to the new name that's been given by the constructor, and I'm going to set the DNA to the DNA of the constructor as well by passing in these parameters. Now we have a simple NFT contract. How can we actually go and instantiate and use this contract over here, basically like also a little blueprint that we want to make multiple instances of? Well, let's go ahead and look at how we can do that. In our MyImport contract, we can go ahead and create an array of NFTs. So let's go and say this is going to be a type of NFT, all right? And we're going to make an array of this NFT. Let's make this array public and let's call it NFTs, just like so. Now this contract knows about NFT because it's in the same scope. It can have access to it. If this didn't exist, if you didn't import this, it will throw an error, but it knows about it. So if you import it, or if the contract's in the same folder, it will know about NFT. Let's go and create a new function down here, and let's say add NFT, like so. This add NFT we're going to make public as well. And the purpose of this function would be to instantiate and create a new contract instance with its own address and actually populate this NFT space. All right. So what we can do now is in this function, we have to define the type, which is going to be the type of NFT. We're going to say this is an NFT, and we're going to equal it to a new NFT contract. How do we instantiate new contracts? Well, we start off with the new keyword. Then we pass in the type that we want to create, which is NFT, and we open our curly, just our normal brackets. Our normal brackets is going to be the constructor values. So usually what you'll have to do is we'll have to also pass in a string memory over here, which will be name, especially if we want to create a new NFT. So a UN256, which by the way, UNT actually is UN256, so you don't have to explicitly say 256. I like doing that because it makes it clear for me when I read code. We also want the DNA field. So now that we have these two parameters coming from the outside, we can go and just specify it in our constructor like so. Now you can see that we have an NFT and we can actually go and push it onto our NFTs. So go and select the array up here and let's go and say push like so. And then when we push this, we can push the new NFT. And that's how we can add and instantiate from a new contract. Let's go and run this program for interest's sake and see what it will do. So we can go ahead and export deploy my imports and see how it will behave. We need to pass it these two constructor values because remember we are importing from ERC 721. So now what I'm going to say is just this is a test and the symbol is going to be test. I'm going to transact and see what it gives me. So obviously it's going to give us all these different functions because remember we are inheriting from ERC 721 and my loop. So all these functions, my loop and everything exists in this contract. Let's go and find the add NFT over there. So we have it. There we go. There's add NFT. Let's go and say this NFT's name is going to be Daniel and the DNA is going to be that. I'm going to go ahead and transact, and then when we look at our NFT index, so here is our NFT array, we have to specify an index. So I'm going to specify index 0, and then you'll see something interesting. It returns to us an address. So this is actually the address of the NFT contract that we created. So if we want to call the functions on that NFT, it can have more functions. We can just specify it how we did in the previous example. But that is a way for you to instantiate new contracts inside other contracts. I'm going to use the same file for the next example when talking about strings. Now let's go to the my imports down here and let's declare a string. Now you've seen me declare a string, and let's call this maybe not name but my name, and you've seen me declare strings and I can do it like this. Alright, and it's perfectly fine. Solidity supports string literals like these being assigned to a variable data type called string. But string takes a lot of gas, and there's another way to interchange them and using bytes. You can similarly do the same by saying that this can be a bytes 32, and let's just call it my bytes name. My bytes name is also equal to Daniel. You can see that this is also perfectly fine to use, and in some cases it's better to use the bytes 32 to declare strings instead of string, and the reason for it is that the bytes take less gas and computation power, so to say. That's why I left this last, to just mention that. I didn't want to confuse you guys, but theoretically bytes is strings, right? It's a conversion of bytes, and that's eventually what strings are. It's an array of bytes coming together. I would like to leave you with a very powerful function that you can use to hash anything into a unique identifier. You can hash passwords. And what is hashing? Basically, to hash something is to take a certain amount of attributes, strings, bytes, whatever it is, and put it through an algorithm that spits out a constant different looking identifier, like an ID. It's usually a large number that can be seen as a unique identifier because it's so unique. Well, in normal programming languages, we have like SHA-256 hashes, but in Solidity, they use the KEKAK-256 hashing algorithm to spit out these algorithms. Now, KEKAK sounds very funny, but it is a very powerful function. Let's see how we can use it. I'm going to create a new function and call it my hashed name. And what my hashed name is going to do, it's going to take in a string. So let's give it a string and let's give it a name. We're going to declare this function as public, open the curly braces, and let's start. All we want to return is a hash. Now, in returning a hash, we can also say that this is going to returns. Now, let's think about this for a second. What is this going to return? This will be returning a bytes. Let's go and return bytes. A bytes 32 would be fine for this. We're going to return a KEKAK hashed name. Now, we can simply return the name like this, right? And that we want to hash. So there's the name that we want to use. And we want to turn it into bytes because we said we're returning bytes. But we want to return a specific amount of bytes. So let's go and use the KEKAK. So you specify the KEKAK keyword like this, and you put it in curly braces. And it can't directly convert the string into the data that it needs to create the hash. So you'll have to use an extra library called abi.encodePacket. So let's say abi.encode, I think it's encode packet, like so. And then once you've encoded a packet, basically concatenating this and creating a byte, you can add numerous different values in here. Just by the way, we can put hello, like so. We can add another one. Maybe we want to add more strings. But anyway, we just have our name. And this function will suffice for what we want to do. And this we can probably make view so that the compiler doesn't go crazy. And then we also have another warning. Oh, it says we can make this pure because we are not touching anything in the blockchain, which is perfectly fine. Let's go ahead and deploy this and see how our hashed name comes out. Remember, we have to still put in our parameters for the constructor up here. So I'm just going to say this is test and deploy a new instance. Let's go and find the my hashed name function, which should be somewhere here. I don't see it though. Oh, there it is. Okay. So there's our my hash name. So let me type in Daniel just like so. And let me call it. And you can see that it spits out a hash. We can change this into anything really and call it, and it gives us a different hash. The wonderful thing about this, if we type in Daniel again, it should give us the same hash over and over and over again. And that's the beauty of a hashing algorithm. If the data is the same that's being hashed, then it will give you the same hash, and you can compare these hashes to make sure that data is what you say it is. And that's a way of encoding things and decrypting it and keeping it safe. That's usually what they do with passwords on normal databases. Anyway, guys, I really hoped you guys understood everything I explained in this tutorial series. I really hoped you guys learned a lot from me, and if you did, please, if you did, go and like this video, like all the videos, go and comment in them, go and subscribe and turn on the bell icon, because I will be doing a lot more of these series with you. After this series, I have now the freedom to know that you guys are equipped with the knowledge of Solidity. There's a lot more difficult concepts to understand in Solidity, but this at least allows me to go ahead and implement smart contracts with the freedom knowing that you guys will be able to follow along after looking at this tutorial series. You will understand the basics of how to create smart contracts so that we can go ahead and create cool things. We don't only want to ever stick by creating NFT contracts. We want to create real world use cases. And that's why I did this tutorial series. So guys, have an amazing day, have an amazing week, and I'll see you in the next video.